Gravimetric analysis is a method used in chemistry to find how much of a substance is present in a sample. It works by measuring the mass of a solid. In this method, the substance we want to analyze is changed into a solid called a precipitate. This precipitate is then collected, dried, and weighed. Gravimetric analysis is commonly used in environmental monitoring. It helps us to check water, wastewater, and air quality. For example, it can be used to detect sulfate and metal ions, which are important pollutants in environment. The principle of gravimetric analysis is based on chemical reactions and stoichiometry. The analyte reacts with a reagent to form a solid compound called a precipitate. It is very important that the precipitate is pure, stable, and has a non-chemical composition. Once the precipitate forms, we go through several steps. We filter it, wash it to remove impurities, dry it to remove moisture, and finally weigh it carefully. The result from weighing is then used to calculate the amount of the analyte in the sample. Gravimetric analysis is a classical analytical technique used in chemistry. Its main purpose to determine the amount of a substance by measuring its mass. The process starts by converting the substance we want to analyze, called the analyte, into a solid compound called a precipitate. This precipitate is pure and stable. After forming the precipitate, we weigh it carefully. From its mass, we can calculate how much of the analyte was present in the sample. Gravimetric analysis is widely used in environmental monitoring. It can determine sulfate ions in water and wastewater, which helps us check water quality. It is also used to analyze metal ions like lead or calcium in water or other samples. This method is important for assessing overall water quality. In addition, it can be applied in air quality studies to measure particulate matter in the air. Overall, gravimetric analysis provides accurate and reliable results, making it a valuable tool for environmental studies.
So for our methodology, regarding wastewater and air quality, the experiment is gravimetric analysis of an unknown sulfate. So for the apparatus, we need 250 ml beaker, 100 ml graduated cylinder, 500 ml aluminium flask, analytical balance, steering rod, retort stand with ring clamp, wire gauze, Bunsen burner, wash bottle with distilled water, crucible and lid, clay triangle, crucible tongs, and filter paper. For the chemical, we need unknown solid sulfate salt, 6 molar hydrochloric solution, 0.1 molar barium chloride solution. For the procedure, first we need to weigh, clean and dry 250 ml beaker, and then we need to add 0.30 until 0.35 gram of unknown sample and record the total mass. Second, we need to add 50 ml distilled water and 20 drop of 6 molar hydrochloric acid. Stir until dissolved. Third, we need to place the beaker on a wire gauze and then heat gently until near boiling, then turn off the Bunsen burner. And then we need to measure 25 ml of 0.1 molar barium chloride and slowly add to the hot solution over 3 minutes. And then we need to stirring continuously. Let precipitate, which is barium sulfate, settle for 20 minutes. And then we need to heat the crucible and lid for 2 minutes and then cool it off and wait the crucible only. Next, we need to fold the filter paper into a cone. Wet the filter paper using distilled water and place in a funnel over a 500 ml aluminium flask. We need to pour the mixture slowly into the funnel, and then we need to rinse the beaker and roll into a funnel with distilled water. Next, we need to cool the crucible and wait, and then we need to reheat for 5 minutes. Cool again and reheat again. Repeat until mass is constant within 0.005 gram. Lastly, we need to transfer the barium sulfate in the proper waste container. Clean all equipment as instructed.
Hi, I'm Nurul Munira, and I'm going to be giving the example of result. So the example here is sulfate determination in industrial wastewater. The method used is precipitation method, and the scenario is monitoring sulfate levels in wastewater discharge from a fertilizer plant. For the process, the first step is the sample of wastewater was measured accurately. Then barium chloride is then added into the wastewater. And then we filter precipitate using a filter paper. Then the precipitate are dried and weighed. And the fifth step is that the sulfate content, which is analyte, is then calculated in form of the barium sulfide precipitate. Next is calculation. So the table above here is the standardized maximum limit to be used in the calculation. Next, we are going to be determining the equation, and we are going to use the information provided. And we are going to be finding the molar mass of barium sulfide on also sulfide. The next step is finding the gravimetric factor, and we're using the formula weight of analyte over weight of precipitate, and therefore we're just including the 96 gmol over 233 gmol, and we get 0.412. Next step is we're going to find the mass of sulfate, and we're going to include the formula of gravimetric factor multiplied by weight of barium sulfide. So that is 0.412 multiplied by 0.143, and we get 58.92 mg after we've converted. The last step is finding the concentration of sulfide. We're using what we get from the previous calculation, which is 58.92 mg over 0.25 liter. Therefore, we're getting 235.68 mg per liter.
In conclusion, the gravimetric analysis of the unknown sulfate was successfully carried out by precipitating the sulfate ions as a barium sulfate, BaSO4. The precipitate was carefully filtered, washed, dried, and weighed to ensure accurate mass determination. From the mass of BaSO4 obtained, the sulfate content of the unknown sample was calculated with good precision. This experiment demonstrated that gravimetric analysis is a reliable and accurate method for determining sulfate ions when proper laboratory techniques are applied. Any minor discrepancies in results may be attributed to incomplete precipitation, loss of precipitate during filtration, or moisture retained in the solid. Overall, the method proved effective for quantitative sulfate determination in analytical chemistry.